So hello everyone, this is me, Shresht Kojbave from the IoT CP team, and I am here to talk something about STL, Standard Template Library. Yeah, this type of topic used to haunt me a lot. Like, why do we use this? Why can't we just use simple arrays, just simple data structures that we learned? I'm gonna do everything using arrays. But once I started learning STL, I found out the power of STL, how it is so very important, and it makes comparative programming especially so easy and so understandable. Like, it reduces your effort by half. It's all why should I just say everything about it? I'll start showing you also. We'll start with the first topic, which is vectors. Now vectors, what are the first question that comes into mind? What are vectors? Vectors are same as dynamic arrays, but they have the ability to resize themselves automatically when an element is inserted or deleted. Now you're gonna say, why do we need vectors? We will use normal dynamic arrays to do this. No need of using vectors. But as the functions and as the different features vectors has that I'm gonna tell you, you're gonna realize how important and easy it is to solve questions using vectors. Now, vectors are placed in contiguous storage, so they can be accessed and traversed using iterators. I'm not gonna go into iterators. My one very knowledgeable friend from the IoT CP team only is gonna tell you about that what are iterators and how are they done. I'm gonna move forward just with the thought of vectors, and I'm just gonna try and introduce you to the concept of vectors so that you get this into your inquisitive mind and try using vectors into your daily coding lifestyle. Now in vectors, what happens is that data is inserted from the last. We use a function known as pushback, which I'll tell you about you in detail also. Don't worry about that. It inserts the after we start doing pushback, it starts inserting the elements from the end. Now, inserting the elements from the end might take a small amount of time. Should be a small amount of time complexity in this because, of course, as we start pushing the elements from the back, there are gonna be resizing, and the size of the vector would change, and this would take some time. But removing the last element takes constant time complexity because we use the function pop and there are no resizing habits. The pop function, what does the pop function do? The pop function basically removes the last element of the vector directly from the vector. It is not something that's going to take you a lot of time. It's just a simple syntax, which I'm going to tell you about also in later. Now, a lot has been talked right now. It's time to start coding and show how the code really works and how it looks, how the syntax basically looks. So we are going to start by initializing right now, which is hash include bits slash std c++.h. Then we are going to say using namespace std. We are going to use this bits header file because it includes the standard template library. Yes, sorry, the namespace std. Sure. Then int main and then return 0. So the basic fundamental and the framework for making a program has been made. Now let's just directly come to declaring a vector. How do we declare a vector? How we write the syntax? It's something like this. Vector int, because here is the data type which we want our vector to contain. If we want long something bigger than int, we will write ll, just like that. Vector int v1. The name of the vector is v1 here. V1 vector we are talking about. Now we want to know, like, how about we ask the user the size which is gonna be of the vector and then make a vector and display it. Let me show you how that program is gonna look. Int n c in n. I'm gonna keep adding some comments here so that you follow up on what I'm trying to convey to you. This is to ask the user the input size he needs. Sure. We got the user for the input size. Now we're gonna run an array which is the size of n, and we're gonna keep pushbacking the elements directly into the vector. How that's gonna look? Let me show you. For loop, we're gonna run a for loop for the length of the n, which means for the length of the vector that is to be made. For int I equal to 0, I less than n, I plus plus, and the next I'm gonna be int x, c int x, and v1 dot pushback. There should be the pushback function. Pushback, yes, x. So what did we do here? Here we made another variable x. We made another variable x, and in that variable, the each element for n times basically, like let's say n is 3, 1 to 3. We are entering 1 to 3. So we're gonna run the for loop for 3 times because n is 3. Int x is going to be 1 for the first time. We're gonna take the value of 1 in a variable and directly push back into the vector. 1 is getting pushed back. Then next time the for loop runs, int x is equal to 2. We take in 2, we push back it directly into the vector. So it goes v1 dot pushback 2, and then same goes for 3. Now here we have now here our vector is made, and it is of the size n. It has the data which is going to be entered by the user. Let's make the print function for the vector. Printing a vector. Before printing a vector, I would like to tell you about a function called v1.size. v1.size, this function basically directly, it's not like an array that you have to run a for loop, you have to count plus plus, you have to take an integer count plus plus, and then you get to know the size. No, not here is how the beauty of STL starts. v1.size, this function basically just directly returns you the size of the array, the size of the vector, sorry, entered directly. So the next for loop that I'm gonna run is to make a print function, basically for printing the entire vector. Yes. Now let me make a print function directly. Basically it's not a function, it's like a for loop. I'm sorry if I used the word function here, but basically it's just a for loop, and I'm just gonna comment it to printing the entire vector. Yes. Now we are gonna run the for loop again for printing the vector, just like we used to read in array. Here we'll start with for int I is equals to. Why should we keep declaring int I? We should declare it here only directly. So that will save us from declaring int I always. Int I equal to 0. Yes. So now for I equal to 0, I less than, just take a look at this. This is important right here. v1 dot size I plus plus. Yes. We just did this v1 dot size, this one is gonna directly return us the size of the vector. This v1, so directly we can put it in the for loop, and this entire for loop will run for the size which is given by the user, which is n here. That's gonna give. We could have written n, but when we don't know the size or it is not given by the user, then it's a good practice to start using v1 dot size. Now let's come to printing the vector. Now it's just basically the same thing which we all have studied while studying arrays. It's cout v1 of I and directly this, because the name of the vector is v1. So we're gonna print v1 of I. Now let's run this program. Save it and run it. Yes. So now it's asking us for n. The first is n. Let's take it 4. Yes, 4. Sorry for the lag if it would be, just bear with me on this. 4. Now we need to enter 4 elements. Now the pushback function will start working from line number 8 till line number 11. Now this should start working. First, pushback, 2, pushback, 3, pushback, 4, pushback. See, it pushed back, made a vector of 1, 2, 3, 4, and here we get a vector, our vector, entire vector printed as 1, 2, 3, 4. So this is how we basically ask the user for elements. We insert it and make it into a vector, and then we print the vector. Now it's not like, yeah, just an important point that I missed, I should write here as a comment, is that the TC, I'm going to use the TC as short form for time complexity. Time complexity of the pushback is O of 1, constant time. It is very fast, as I told you. That's why vectors are so useful. Now, it's not like here we had declared the size of an array. We had asked the user for the size, and we had declared the size according to that. We can also pre-declare the size of the array. How to pre-declare the size of the array? It is going to be vector int. I'm going to just put some spaces here so that you don't get confused. Yeah, this is a new vector we are talking about. Vector int v2 10. So now we have made a new vector v2 of predetermined size 10. We're not asking the user for the size. We have a predetermined size 10, but, there's a big but here. In array, if we had declared an array of size 10, that means it is fixed, completely fixed. We cannot add a new element or this without changing the size of the array. In vector, we have written this 10, but it is not fixed. We can always do v2 dot after entering, this is after entering 10 elements. We can always do v2 dot pushback 1. If we do it after entering 10 elements, the 11th element would become 1. Another element would get added to it, and then we don't have to change the size of here back to 11. No, this is not required. Just let it be 10. And if we, after entering 10 elements, if we add another element, it will directly get entered into the vector. Now, the next thing is pop function. How do we write the pop function? The pop function removes the, as I told you, the last element of the vector directly. Pop function is written like somewhat like this. Now let me remove this. We are going to talk entirely about v1 in terms of v1 vector only, so that we maintain the consistency here, and we don't lose track of which vector is what, and it is uniform. So v1 dot pop back. v1 dot pop back. This function is going to pop back the last element directly. So now what should I do is that if I cut it and if I place this right here before printing the vector, now let's see. We are going to add 4 elements 1, 2, 3, 4, but we should get the answer as 1, 2, 3 only because we have used the pop back too. Yes. We enter the size, which is 4 here directly. It's taking a little bit of time, so sorry for that. Yeah, we've got the 4 here. After such a after such a lot amount of lag, we've got 4 here. Thank God. Now we entered 4. Now we need 4 elements. 1, 2, 3, 4, and print function. See, beautiful. We entered 4 elements. Then on line 13, after entering all the elements, we put a pop back function. It removes 4, and when we print it, we don't get a 4 because it's removed from the array. It's popped back. We only get 1, 2, 3. I hope this is clear from here. Now the next is that what I'm going to use, I'm going to tell some concepts real fast so that it doesn't get boring for you and you can go on with what you're doing. Yes, the next concept coming is copying a vector directly, which is going to be vector int. Just see the syntax here right here. v2 is equal to v1. This means, let me comment it right here so that you can see. The comment which I'm doing is this directly means that the entire v2 is the entire v1 is now copied into the v2 is now copied into v2 directly. The entire vector 1 2 3 4 which we had, now v2 is also 1 2 3 4. We never had to, like in an array, we don't have to like run two for loops, start entering each element into the next one by one, one by one, one by one, or even using one for loop. No, just using a vector int v2 equal to v1 directly in one step, the entire v1 is copied into the v2. Another beautiful function, really beautiful one, is the sort function. What the sort function is going to do? Sort. I'm going to tell you what it's going to do. Sort v1 dot in. Now the facts of how we write the sort using vectors. Sort is one of the few beautiful features I personally started using vectors myself, and I remove the fear of vectors with v1 dot end directly. Now let me show you this. I have to show this syntax. I have to show working for this. This is going to, let me comment this out also. Now let me completely remove it. Yes. Let me remove the pop function. Now this is an array. Let me remove the pop function and place a sort here so that before printing we have the vector completely sorted. Okay. So line number 21 goes into directly your line number 13. Yes. Now let's see what's gonna happen. What's gonna happen is that I play this, and again they ask me for this. I enter 4, and it's gonna take some time as usual. Yeah, you can just skip this part right here. You can just fast forward this. Yes, thank God this was fast. 4. We enter random numbers, not 1, 2, 3, 4, 5, 10, 2, 1. See, it took the array. It took the elements 4 vectors, not the array. Sorry about the word array. Made it into a vector. Line number 13 comes into play after we accept it all and push back. It sorts just this one single beautiful line, sorts the entire vector, and we have the entire sorted vector printed in front of us. Direct. No, nothing else algorithm to follow, steps to follow, no. Just this little line number 13. So I hope you get this. This is very important. Used for directly sorting in increasing order. Yes. Now, the next is, the next I'm not going to type anything. I want you to just listen to me very carefully. I'm going to introduce you to the concept of upper bound and lower bound. These are going to be explained later, I hope, by my very knowledgeable friends who's going to teach iterators. But if it is not clear, if it is not covered there, I just want you to have a good knowledge of this. And you can then look up on any website and grasp a deeper knowledge. Upper bound and lower bound. The first, let me make some notes for this here, like in the comment section. Notes for upper bound and lower bound. Point number one. Let me do it like this so that it gets commenting. Point number one is, first we have to sort. For using upper bound and lower bound, it is imperative to have a sorted vector. First you have to sort the vector for using the concept of upper bound and lower bound. Now what is lower bound? The lower bound feature, it basically finds the element that we want and returns the element greater than that element if that element is not present. I'm going to show you this using a very simple example. Don't worry. It's going to look a lot intimidating right now that what is if not present, present, this sort of words. For upper bound, the element to be searched, if we give it an upper bound command, then also it will display the next element only. Okay. Now these were the formal definitions which I had to do. These were the jargons which I had to tell you. Using a very simple example, it's going to be real clear what is upper bound and lower bound. Yes. Imagine 4, 5, 5, 7, 8, 25. A, 4 is A, B, C, D, E, F. We have given this A, B, C, D, F so that while now that I'm explaining, it's going to be a lot clear to you. Lower bound of 5, we will get B, which is 5. Because lower bound said, now I'm going to switch to Hindi for this one so that बहुत अच्छे से समझ में आएगा. लोअर बाउंड ये कह रहा है कि अगर आपके पास एलिमेंट है जिसके लिए लोअर बाउंड लिया है तो वो एलिमेंट रिटर्न कर दो सीधा, और अगर नहीं है तो जस्ट उससे बड़ा एलिमेंट रिटर्न कर दो. यहाँ तो 5 का लोअर बाउंड चाहिए, 5 वी ऑलरेडी हैव. नाउ लेट मी शो यू अनदर एग्जांपल. लोअर बाउंड ऑफ 7, lower bound of 7, we are going to get directly D is the output because 7 is already present here. अब असली में क्लियर होगा आपको. Lower bound of 6. 6 is not present in the entire vector. 4, 5, 5, 7, 8, 25, no 6. Lower bound says अगर तो वो एलिमेंट है तो वही रिटर्न कर दो, और नहीं है तो उससे एक बड़ा, just the next one to that, because it is sorted, so the next one is definitely going to be the बड़ा, उससे just बड़ा. So the lower bound of 6, D will be the answer. 7, because it is just bigger than 6. I hope the lower bound concept is clear. Let's quickly wrap up the last concept, upper bound. Upper bound, upper bound कहता है कि अगर वो एलिमेंट है कि नहीं उसे फर्क ही नहीं पड़ता है, आपको तो नेक्स्ट ही एलिमेंट पकड़ाना है. वो एलिमेंट प्रेजेंट है कि नहीं है दैट आई डोंट केयर, यू हैव टू गिव मी द नेक्स्ट टू दैट. अपर बाउंड ऑफ 5, ये तो एक ही एग्जांपल में समझ में आ जाएगा. अपर बाउंड ऑफ 5, we will directly get D. Directly get D here, which is 7. क्योंकि उसको 5 है कि नहीं उसे मतलब ही नहीं है, उसको तो नेक्स्ट एलिमेंट चाहिए. Yes. So with just one concept, it's not a concept I would like to conclude this session, is that upper and lower bound both return locations. I'm gonna repeat it again. Upper and lower bound both return the locations, which is iterators. In case of vectors, array होता तो pointer return करता, upper bound lower bound. Vectors है तो iterators return कर रहा है. Iterators you're gonna study what it is iterators, but I'm just gonna tell you that it returns the location and not the value right now, right there. Okay, it returns the location. That's important. So thank you very much. This has been me, Shresh Kochkave, trying to get to you a little concept of vectors which will get into your inquisitive mind, and you'll at least go on Geeks for Geeks or any other site and start studying about this, and start using this into your competitive programming code. Please forgive me if I got some factual errors, and because this was also my first time recording in front of a screen. I hope something has been there. Even if 1% has been there, that's enough for me. Thank you for bearing with me. I hope you have a great day and all the best for your future.
Let's move on with the next topic, that is set. Set is a data structure which stores only unique elements in a sorted order. For example, अगर मेरे पास मान लीजिए यहाँ पे 5 नंबर हैं 1, 2, 3, 3 एंड 4, और इन सभी को मुझे एक ऐसे कंटेनर में ऐड करना है जो सिर्फ यूनिक और सॉर्टेड ऑर्डर में स्टोर करें. तो इसमें मैं पहले 1 डालूँगा, फिर 2 डालूँगा, फिर 3 डालूँगा, फिर जैसे ही एक और 3 मैं ऐड करूँगा इसमें, क्योंकि इसमें पहले से एक 3 प्रेजेंट है, ये इस 3 को उसमें इंसर्ट ही नहीं करेगा। फिर हम नेक्स्ट पे जाएंगे 4। तो मेरा सेट अगर मैं देखूँ तो वो दिखेगा 1 2 3 और 4। तो दिस इज़ द बेसिक फंक्शनिंग बिहाइंड द वर्किंग ऑफ सेट। और सेट के बहुत सारे फंक्शंस हैं जो आप यूज़ कर सकते हैं, लेकिन मैं मेजरली दो तीन ही मतलब बताना चाहूँगा आपको जो कि ज़्यादा यूज़ होते हैं डेली प्रॉब्लम सॉल्विंग में। ऑब्वियसली यू कैन रेफर टू द रिसोर्सेज इन द डिस्क्रिप्शन लेटर ऑन, बट आई वोंट बोर यू गाइज विद इट। तो पहला है, अगर हमें फाइंड करना है कि सेट में ये पहला एलिमेंट कौन सा प्रेजेंट है, तो क्योंकि ये फंक्शन, जैसे मान लीजिए मुझे ये फाइंड करना है, तो ये है बिगिन, मतलब फर्स्ट ही एलिमेंट है। और इस सेट का नाम मान लीजिए मैं देता हूँ, इस सेट का मान लीजिए नाम रख देते हैं जेड रख देते हैं, ठीक है। सेट का नाम है जेड। तो जेड डॉट बिगिन को जैसे ही मैं प्रिंट करूँगा, ये मुझे बताएगा कि यहाँ पे कौन सा एलिमेंट प्रेजेंट है। जैसे, और क्योंकि ये हमारे पास एक इटरेटर देगा, तो यहाँ पे एक स्टार लगाना भी ज़रूरी है ताकि वो उसका रेफरेंस यूज़ करे। तो इसी तरीके से जैसे बिगिन है, एक और है हमारे पास डॉट एंड फंक्शन, मतलब नेम डॉट एंड। फिर आर एंड, मतलब रिवर्स में एंड, जो कि आपको बिगिन का एलिमेंट देगा। और फिर एक आर बिगिन, जो कि आपको रिवर्स में फर्स्ट एलिमेंट देगा। जैसे 1 2 3 4 हुआ, तो एंड हमें देगा 4, और बिगिन हमारे पास दे रहा है 1। जैसे आर एंड तो रिवर्स में ये वाला देगा, और फिर आर बिगिन ये देगा हमें, ठीक है। और उसके बाद दो और बहुत ही इंपॉर्टेंट फंक्शंस हैं। एक है सेट डॉट फाइंड, तो ये हमारे पास वो एलिमेंट का पोजीशनिंग देगा कि वो कहाँ पे है, और ये भी हमारे पास एक इटरेटर ही रिटर्न करेगा, जैसे मैं 3 फाइंड करना चाहूँ। और दूसरा फंक्शन जो कि बहुत ज़्यादा यूज़फुल है वो है सेट डॉट काउंट। ये एक बुलियन फंक्शन है। जैसे मान लीजिए मुझे 3 का काउंट फाइंड करना है, तो ये बुलियन फंक्शन तो नहीं है, लेकिन क्योंकि सेट में सिर्फ यूनिक एलिमेंट्स ही स्टोर हो रहे हैं, जैसे 1 2 3 4 है, तो सेट में कभी भी 1 2 3 3 4 स्टोर नहीं होगा। तो जो काउंट होगा किसी भी एलिमेंट का वो मैक्सिमम 1 जाएगा। तो जैसे अगर मान लीजिए मैं इस काउंट का ही रेंज लिखूं, तो ये 0 से 0 रहेगा या 1 रहेगा। तो अब जैसे मान लीजिए एक क्वेश्चन सॉल्व करके ही बाकी चीज़ें समझते हैं कि सेट हम यूज़ कब करते हैं। तो अगर मेरे पास एक क्वेश्चन है कि एक आपको स्ट्रिंग दिया गया है, और इसमें से आपको बताना है नंबर ऑफ यूनिक एलिमेंट्स। तो एक स्ट्रिंग ले लेते हैं, मान लीजिए एस है हमारे पास, मैं अपना ही नाम ले लेता हूँ, सामर्थ राज। सो दिस स्ट्रिंग कंटेन्स लोअर अल्फ़ाबेट्स ओनली, ठीक है। अब एक हम सेट क्रिएट करेंगे यूनिक एलिमेंट्स फाइंड करने के लिए, क्योंकि सेट का बेसिक फंक्शनिंग वो है। तो सेट हमने क्रिएट किया, सेट आगे लिख के, और यहाँ पे इसके बीच में इसका डाटा टाइप डालना पड़ेगा। तो डाटा टाइप, क्योंकि हम एक कैरेक्टर्स इसमें इंसर्ट करेंगे, तो सेट ऑफ कैर, और इसका नाम मैं दे देता हूँ ST। अब मैं इसमें, ये हमारा सेट हो गया, मान लीजिए ये कंटेनर अभी हमने इस डिक्लेरेशन से क्रिएट किया, और हम इसमें पूरे स्ट्रिंग में इटरेट करेंगे, और हम हर एक एलिमेंट को इसमें इंसर्ट कर देंगे। तो पहले एस ऐड होगा, फिर ए, फिर एम, फिर क्योंकि ए ऑलरेडी प्रेजेंट है तो ये नहीं आएगा, मतलब ये सेकेंड ए इसमें इंसर्ट नहीं होगा। फिर आर, फिर टी, फिर एच, फिर ये आर भी नहीं आएगा, ए भी नहीं आएगा, और फिर जे। तो 1 2 3 4 5 6 7, तो नंबर ऑफ यूनिक एलिमेंट्स हमारे पास टोटल आए हैं 7। तो हमें एक प्रोग्राम लिखना है जो हमारे पास ये काउंट रिटर्न करेगा। सो लेट्स सो लेट्स जस्ट डाइव इनटू द कोडिंग पार्ट ऑफ दिस, just a second, yeah. So this is a pre-included library. This contains all the libraries that are present in the C++. but there is an external library, matlab in case if you don't want to use the first library that I'm using, bits std c++, there's a specific library for set, that is include set. But now when we are using the first one, we don't need to write this. I was just showing it to you for the information. And now, yes, so now when we understand the logic, we need to code down. I would really recommend in this one also for you to code it on your own, and if you are unable, then you can obviously look at answers. So first we'll declare a string s, that is Samarth Raj. Now I want to print only the number of unique elements. So let's declare a set of char st loop और st dot insert s of I. हर एक एलिमेंट को हमने उस सेट में डाल दिया है. अब हमें सिर्फ सिंपली चेक करना है कि इस सेट का साइज़ क्या है, क्योंकि साइज से ही हमें काउंट भी पता चल जाएगा कि स्टैक में सिर्फ इतने ही एलिमेंट्स प्रेजेंट हैं और वो सारे यूनिक ही हैं हमारे पास. तो हम सिंपली कर देंगे सी आउट एस टी डॉट साइज. नाउ लेट्स execute the program. Yep, we got the output, it is 7. So that's it by my side. Thank you.
Hello guys, my name is Ansarkar and I am currently pursuing my second year in CAC branch at Kalinga Institute of Industrial Technology Combination. I'm also a team member at IoT Lab and I'm currently a part of the CP team. And today we'll be discussing about maps, unordered maps, multi-maps and unordered multi-maps. And we'll try to look at how they're implemented internally. We'll try to look at some code implementations, and at the end, we'll also try and solve a sum based using maps, right, on lead code. So without any further ado, let's get started. So first off, what exactly are we going to learn today, right? So as I said, we'll be learning 4 things: maps, unordered maps, multi-maps, and unordered multi-maps. But before we dive deep into these structures, it's important to know what category they come under, right? So in STL, these 4 types of data structures come under a category known as associative containers, right? So what are associative containers? An associative container is basically a variable sized container which helps in storing data in the form of key value pairs, right? So let me just show you an example. Uh, what you see here is an example of an associative data structure, associative container. So it's like this is a variable sized container, all right? So just like vector, you can add more and more elements and it will automatically scale up to accommodate all the data. This is somewhat similar. So until your system memory runs out, it will keep on expanding and it's going to incorporate as much data you throw at it, right? So this is an example of an associative container. So what is happening here is that we have a list of keys, right? So K1 through Kn are the keys. And then we have a list of values which are V1 through Vn. What happens in this container is that K1 is mapped to V1. Similarly, K2 is mapped to V2 and all the way through, and Kn is mapped to Vn, right? So what happens is that when you try to access an element based on the key. Suppose if I ask what's the value at position K2, what is the value which has the key K2? So the associative container is going to look up for K2. It's like, okay, here's K2. And then it's going to tell me that, okay, K2 is mapped to the value V2. So the value which you want is V2. So it's going to return me V2, right? So that's an associative container. We are storing data in the form of key value pairs and they are efficient, right? How are they efficient? The keys which you see here are designed in such a way that the lookup time is as low as possible, right? It's as fast as possible. So what that does is, since we can look up the keys really fast, that means we can also look up the associated values really fast. Okay, so that's the entire thing behind associative containers in STL. Okay, so I think we can get started with maps now. First of all, the structure, like how am I going to explain it? So first of all, we'll be explaining the formal definition. What are maps? We just saw about what are associative containers, and we'll be looking about maps, and we'll take a look at the syntax, how how you're supposed to declare maps in C++ STL. We'll see a short code implementation. I'll be showing you the various functions which are used in STL maps, and those functions are also extendable to other other containers of the family. So like unordered maps, multi-maps, almost the same thing. And then we'll be talking about a few applications, and we'll also be solving some from lead code. All right. So cool. Let's get started. So first of all, maps. As I said, maps are associative containers, right? So they store data in the form of key value pairs, and that's all there is to a map. One important feature of a map, though, is that maps in STL do not allow duplicate keys, right? So, for example, if I have a map which says roll number 787 maps to Ansh Sarkar, right? So the key is 787, and the value stored at that key is my name, so that's Ansh Sarkar, right? But if I try to put in another value with the same roll number, that is 787, then obviously two students with the same roll number can't be there, right? So STL maps is going to return me an error. It's going to say that no, bro, you can't add two keys with the same values, right? So it's like two same keys cannot be added. Duplicate keys are not allowed in C++ maps. Okay, STL maps. But this is not the case in case of multi-maps, right? We'll come to multi-maps later. So just remember right now that these are the features of maps. And one more feature of map in C++ is that maps sort the data, right, based on their keys. So I'll be showing this in the code implementation as well. The keys in the map are sorted in ascending order by default. Okay, so that's another property of maps. So let's coming down to the syntax of maps. So here's the syntax. So we declare it using the keyword map, like that's the name of the structure container. And for in order to use map, this is important. We need to import two header files, right? So we need to include something known as the map header file. So hash include, and we'll include map, and we'll also include something known as the iterator header file. So hash include. What's wrong with include? Okay, include include and iterator, right? So iterators help us to iterate over containers, and map is the map which we're using. So we'll be using this and key data type. So every map has a key, and it has some value stored at that particular key, right? So the key can be of a different data type, and the value can be of a different data type. So that gives us the flexibility to you know tailor our map to our needs. So this is the key data type. We'll pass what type of key do we want, what is the data type of the key, and what is the data type of the value independently, and we'll also give the map a name, all right, so that we can reference to it in future. So that's all it takes to declare a map. And there are other things like how do you initialize a map using some other map, and all those details we'll be seeing it in the code implementation, right? So okay, I guess it's time to give you a small demo of like how maps work and the most common functions used in map. So let's just switch to VS Code and do a bit of coding. Right, so now I have switched on my IDE. So I have this file created, and this is the most basic C++ template, which I guess most of you are familiar with. So first of all, we'll be starting off with maps. Like I'll show it for maps, and unordered maps, multi-maps, and unordered multi-maps follow almost the same syntax. So we won't be coding all of them separately. I'll show you the most used functions in maps, and then we'll move on with a theory, like how they're implemented internally, and we'll read it after the code implementation, right? So starting off, in order to use maps in our code, we need two libraries. So they're a part of the standard template library STL. So include, and we'll first include map, right? That's number one. And then we'll also include an iterator library. So what happens is that in STL, whenever you try to iterate over a container, you don't get an exact value, right? They return you pointers to values. So in order to iterate over a container, you need something known as an iterator, right? So if you don't have idea about iterators, then there are plenty of videos on YouTube. You can just go and search about them. Although like I'll be covering them, like I'll be covering the basics a bit. So it might just be clear, but then in just in case it's not, like just feel free to go and search it up on YouTube, right? Anyways, so first of all, let's get started. We have imported the required libraries, and let's start with creating a map, right? So in this example, I'll be creating a map of like type integer, and I'll be naming it as MP. Uh, okay, let's name this as MP1, right? So now the point is that the values which are passing here, this is the key, right? This is the data type of the key, and this is the data type of the value which we're going to store at that particular key. Now there's absolutely no restriction as to what types of values can be keys and what types of values can be like values. Um, you can use anything here. Like it could be an integer, it could be a float, character, string. It could be a more complex data type. It could be a pair of integers. It could be a pair of integers. Like anything, right? Anything works. But for this tutorial, like for simplicity, we'll just stick to integer and integer, right? So we have a key of data type integer, and we also have the values stored at that key, like mapped to that keys as integers, right? Okay, so we've just created our first map, so congratulations. But how do we insert values in it, right? So there are a few methods which we can use. So the first method is mp1.insert, right? So insert is a function, and we'll be passing it as a pair, right? So in case of map, what happens is that this int which you're seeing, it's internally stored in the form of pair int, right? So every element in the map is nothing but a pair of two integers, right? So that's important to remember. Keep that in mind. So whenever we insert, we want to insert a pair of integers with some particular value, right? So suppose I want to insert say 1 comma 40, right? So in this case, I'm inserting a pair into this map. The key of this pair is 1 and the value is 40, right? So this is one way of it. The next way could be mp1.insert. If you don't want to write this, like in case you're not using integer here, right? As I said, it can be anything. So if it's like really complicated like object that you're storing in a map, then this can be kind of cumbersome, right? You will have to write it like it's going to be a long thing to write. So what you can do is you can just write it as make pair, and then you can do the same thing 2 comma 50, and then this essentially does the exactly same thing. Make pairs. It takes 2 and 50, converts it into a pair, and then stores and it inserts it into our map. Right. That's method number 2. The second thing which you could do is like the most common method, I would say, is like just mp1 3 equals to 60, right? So simply use square brackets, enter the key which you at like the place at which you want to store a particular value, and then just pass it pass it a particular value, right? So in this case, 3 is our key and 60 is our value. So 60 is mapped to 3 in our map. Okay, so like this is a really simple and efficient way of inserting values to a map. And the last method is like a shorthand for the insert method. So it's like insert, and rather than using make pair or trying to define like pair int, what all you can do is that just use curly braces and just put in the value. So 4 comma 70, suppose, right? So this does the same thing. Okay, suppose it's like on like a special note, pair int, right? This is what we are doing, so that's why we are using x comma y, right? This is the format which we are using. But suppose you had something like pair, and then there's another pair, and there's int, and there's another int, something like that. Okay, so even in this case, you can use the same notation. All you need to do is that just nest these curly braces. So if I write x comma y, then this is x comma y is for the internal pair, like this pair which you see right here. Okay, and then if you want to initialize this int value, then you can just do a comma and then you can do z. So that it's simple. Okay, it's a easier way to define pairs. Just keep it in mind. Okay, so with that we have inserted values in our map as well. Okay, so awesome. But then how do we see these values, right? How do we see what are the values which are present in our map? So for that, we'll obviously have to create a display function. So let's go ahead and do that. Void display, and let's pass it a map, right? So map of type integer, and then I want to pass this map by reference because maps can be huge and you don't want to pass them by value. Okay. So and MP, so we pass the map by reference. And now iterating over a map can have a few, we have a few different methods for iteration. Let's walk through them one by one. Okay, so you remember this library, right? The iterator library, which I just said at the beginning of the video. So let's use that first. So this is the most complicated one, which I never use, but let's just show it to you once. So for map int, int, so that's the type of container which we are using, and we want an iterator to that container. So we'll write iterator, and then we'll name the iterator as say itr, and we'll initialize the itr to the beginning of the map, right? So map.begin. So this begin function, it essentially returns you a pointer which is pointing to the beginning of the map. Okay, so that's an important pointer, so remember that, mp.begin. So we have created an ITR, which is an iterator to the container map of type integer integer, and which is currently pointing at the beginning of that container. Okay. So while this pointer does not reach the end of the container, while ITR is not equal to mp.end, right? While it's not equal to the end of the container, we'll keep incrementing ITR. Okay, so we'll keep it. So this is the most complicated version, like for iteration over an over a container. And like the thing is, we are getting pointers, right? We are not getting exact elements, so you need to keep in mind that we have to access those values using pointer notation. I'll give you an example. See, cout, and since itr is a pointer, it is not an object, right? It's not an element. So itr, and then to access values in a pointer, we use the arrow notation, right? So we'll be using itr first. This points towards the key. So this is the first, and then this is the second, right? So we will be pointing it like that. And let's try this. Let's format the output a bit so that it looks nice. And then itr second, this is the value which is stored at that key. Okay, and then this should work. Okay, semicolon. Yeah, so this should work. And let's call the display function from our main method, display and mp1. Let's try it out. Okay. Yep. So we got these values. These are the values here. So awesome. Our display function is working good, but this is like too cumbersome, and like if you're in a competition or something, you don't want to use it like this. Okay. So what most of the people use is like they do it auto. Right? So C++ has this feature in which it can automatically infer the type of variable which you're using. So like you just write here auto itr mp.begin, and C++ will do all that map iterator thing internally, right? So this is a much better way of doing it. So if I run this, then this should give me the same output. And yes, so it gives me the same output, right? Let me show this here. Yeah, so this gives me the same output, 140 to 50, right? Cool. But then even this is not something which I like. I think the best method which I've come across so far is using the for each loop to iterate through maps. So it's like for, and then you do automatic inference, and kv pair, like you can name this anything. I name it as kv pair because it stands for like key value pair, right? So key, for every key value pair in the map, what we do is that, and the best part is that this does not return us a pointer. Okay, so this is an important distinction. This is not going to return as a pointer, rather it's going to return as a pair. Right? So this kv pair is going to hold a value which is of the type pair integer integer. So it's an element. We will not be using the arrow notation to access those values, right? So I'll show you to you. Cout kv pair, and since it's an object, it's a pair, we can use the dot operator instead of the arrow operator, right? So let's use this, and kv pair dot second, and then this should work just as well as the previous ones. Okay, cool. So even this works, right? So we'll stick to this one because like I think this is the most efficient and elegant looking solution. So we'll stick to this one, right? So this is our display method. Our display method is done. So now we can insert elements. We have created a map. We have inserted elements to it, and we can iterate over the map using 3 different methods. Okay, so good job. Coming up next, many a times it happens that if I create a new map and I want to initialize it with the values present in some older map, right? So I want to copy those values from one map to another. So how do we go about doing that, right? So for doing that, let's take an example. We create another map identity, same type obviously, and let's name it as map number 2. And for initializing it with the values of map number 1, what we'll do is that we'll pass map 1 to the constructor of map 2, right? So in order to pass the entire map 1 to the constructor, we'll be using map 1 dot begin. That means starting from the first element of map 1 all the way up to the end, we are going to copy all those elements into map 2, right? So whether this works or not, let's just comment this out and we'll display map 2, display map 2, and then this should have exactly the same values which were there in map 1. Okay, so we have initialized map 2 with the values which were previously present in map 1, so that's working fine. Okay, cool. So now we know how to initialize one map object using another one. So moving on, let's learn how to erase stuff, right? So first of all, what we need to understand is that what you see here is 1 and 40, right? So all these things which are there on the left hand side are the keys. So 1, 2, 3, and 4 are the keys, and 40, 50, 60, 70, these are the values. Okay. An interesting property of maps is that maps sort the data in ascending order, right? And by data, I mean they sort the keys in ascending order. Right? So for example, if this is 30 and if I convert it to 80, right? If I convert it to 80 and if I try to print it again, then you will see something. Yeah. So you'll see that the order does not change, right? So it's still 1, 2, 3, 4. It was 1, 2, 3, 4, but the value does change. So it's pretty clear that the map is not sorting values, right? It's not sorting values. But if I just do this as 60, like I take this back to 60, but I change this to 5, right? And if I display it again, so you can clearly see that this time it's sorted 1, 2, 4, and 5. 5 goes at the bottommost value, right? So that's the speciality of maps. It by default sorts the data, structures the data as a binary search tree. So everything is sorted in ascending order, right? So that's something you want to remember about maps. Anyways, now let's try and delete a few values from maps, right? So the first method is like deleting a particular key from a map. It's extremely easy. So mp2 dot erase and just name the key. Like suppose I want to delete the fourth key, right? So I do like this and I just, okay, we need to display it again. So let's bring this display function just after we erase the value. Okay. And then we should see that the fourth key is no longer there. Yes, so we don't have the fourth key anymore, so that's done. Now it might also be possible that you don't want to delete things one by one, rather you want to delete things in a range. So in that case what you could do is that mp2.erase, and for defining the range, suppose I want to delete everything from the start all the way up to the third key, right? So mp2 dot begin. So this is, I'm saying that I want to start from the beginning of the map, and then I want to delete all the values up to, say, I want to delete all the values up till 3, right? But I'll pass it 4 because it's going to delete all the values up to n minus 1. All right, so that's another thing which you need to keep in mind while you're using erase on ranges, right? So if I run this, yeah, so we have deleted every value except for, and like that's because, as I said, is going to find like the iterator which it returns, mp2.find returns, is going to point at one element behind 4, right? So that's why we delete 1, 2, and 3, and 4 does not get deleted. Okay, so that's how you erase elements. So we now know how to erase a particular key. We know how to erase a range of elements. Cool. So now a few general methods which like everyone should know about. So we'll just talk about it. let's comment these things out. We have our map. Okay, this is fine. And we don't want to display it. Okay, let's just display it. And a few things, few utilitarian functions. The first one is the size of the map. Okay, so if I want to show the size of the map, then it's simple. Just do mp2.size and you'll get the size of the map. Okay, it's that simple. And suppose I want to check whether the map is empty. So is empty and then mp2.empty, right? And then suppose I want to see what value exists at a particular key, right? So suppose I want to see what is the value that exists at key number 5. So I'll just write cout value and then mp2 dot add, and then I'll pass the key. So suppose I want to see what value is stored at the third key, right? So I'll write 3 and then that's it. Okay. So let's try to run these functions. Let's see whether they work. Okay, so size empty. So okay, sorry, the size is 4. So 1, 2, 3, 4. We have 4 elements in the map, and is empty returns 0. So 0 means false. That means it is not empty, and the value at 3 is 60. So we can clearly see that the value at 3 is 60. Okay, cool. Now another function, the last function which we'll be talking about is the clear function, right? So sometimes it may happen that you want to reinitialize a map, and in that case you want the map to start from scratch, right? You want to delete everything which is there in the map and like just clear things out. So as the name suggests, just do mp.clear, mp2.clear, and your work is done. So now if I do display, I'll just copy all this stuff, right? I'll just copy it from here. I'll copy this and I'll just paste it here. Okay, and let's see what comes out. Okay, so we can clearly see. I think I didn't format it well. Give me a second. mp2.clear. Okay, okay. It's happening because I didn't format it well. /n/n. Okay, let's try it again. Awesome. So we can clearly see that when I display the map for the first time, so this is display M2, I get all the values. I get the size as 4, is empty is false, and the value given at 3 is 0, right? Now, what happens when I do clear, mp2.clear, and then I display it, I see that nothing gets printed. That's because the map is empty, right? And the size, so the size is 0. Is empty returns 1, which means yes, it's true. So the map is empty. That's what it's saying. And when I try to access the value at 3, it gives me an error saying out of range. That's because the key 3 doesn't not exist in the map anymore, right? So that's how you clear an entire map. And so those are the basic functions which you need to know about maps in order to use them in various weight competitions or in order to solve problems. So we'll look at a sample problem real soon, but before that it's time to go and check out how maps work internally. What's the internal implementation behind maps, unordered maps, multi-maps, and unordered multi-maps. All right. So I guess that code implementation was pretty clear, and a lot of your doubts might have been solved by that, and you might have just got some good clarity over maps now. Let's jump to the internal representation and implementation. Like, how do maps work internally? How are they implemented at the basic level, right? At the computer level, what's the logic that goes behind it? So first of all, let's just understand the brief difference between maps and multi-maps. Okay. So the thing is, the only difference between maps and multi-maps is that, yeah. So difference between maps and multi-maps. The only difference between maps and multi-maps is the fact that maps don't allow us to store duplicate values, right? So we had discussed this before as well. Maps cannot have two keys with the same name, right? But in case of multi-maps, that's allowed. Okay, so you can have uh, two values mapped to the same key. Okay, so that's allowed. So the only difference between maps and multimaps is that maps do not allow duplicate keys, multimaps allow duplicate keys. Okay, both maps and multimaps sort the data in the sort the keys in ascending order. Right, we had learned about this earlier. The only difference is now you might ask me that what are unordered maps, right? What are unordered maps and what are unordered multimaps? So unordered, as the name suggests, maps sort the data. Unordered maps don't. Okay, so that's the difference. So what's the advantage of sorting data in maps and what's the advantage of not sorting the data in unordered maps, right? So the advantages of maps is that sometimes you do need sorted data. You want to preserve the order in like say ascending order. Okay, so you'll be using maps in that case because it's going to always have the keys in ascending order, so that can be beneficial in some problem statements. But the problem with maps is that since it needs to be sorted, the insertion time is log of n. The insertion and deletion time in maps and multimaps is log of n because they internally implement something known as a binary search tree, a balanced binary search tree. All right, and for inserting or deleting in a binary search tree, you need log of n, big O of log n time complexity, right? So I think that's a disadvantage of maps because since you have to keep it in sorted order, you have to do the trade-off, right? So you have to give it log n time, where n denotes the number of elements which are already present in the map, right? So the more number of elements you have, the more time it will take to insert it. But then big O of log n is not such a bad time complexity. It's like it's good enough. But unordered maps can perform even better, right? So unordered maps internally they implement something known as a hash table, right? So if we just look at a hash table, so this is a hash table. So what it simply does is that it takes the key, it passes it to a hash function, and it generates a unique integer, and it uses that integer as the key here, right? So what happens is that it's much faster. You don't have any ordered, you don't have any order in an unordered map. Okay, so it's not sorted. The data is not sorted. The data can be in like any random fashion. You put it there, so you know that the data is there, but you don't know like in what fashion is it sorted. There's no pattern there. Okay, so that's unordered map. And the advantage of not having to sort the data internally results in an O of one average case time complexity, right? So it's like really fast. It provides you constant time access to in the average case. Okay. There are something known as collisions which we won't be going into. So in case of collisions, the time complexity of maps does increase a bit, but then in case it all depends on your hash function, right? So the better the hash function, the more randomized your hash function, the more distributed your hash function, the better your map is going to perform. And we don't have to do all that. C++ STL takes care of that for us. So unordered maps in C++ STL, just assume that they give you constant time access, and they're pretty good and they're fast. But then in case you want sorted data, you should go for maps and multi-maps. The main difference between unordered map and unordered multi-map is the same difference between maps and multi-maps. In case of unordered map, you cannot have like duplicate key values, but in case of unordered multi-map, you can have duplicate key values, right? So that's the only difference. So the internal implementation is important to know. In case of maps and multi-maps, it's a balanced binary search tree. Time complexity is big O of log n, and in case of unordered maps and unordered multi-maps, it's a hash table which is used, and the time complexity is O of 1 in the average case, right? So with that, we now understand the difference between maps and multi-maps. We understand what are unordered multi-maps, what are multi-maps, maps, and unordered maps, and how they work internally. I've already shown you the code implementation, which is extendable to all the associative containers which are out there, and all the four associative containers which we just talked about. And I guess that's the entire implementation. That's maps in C++ in a nutshell. And I think it's time for a quick look at a good question. So let's hop to lead code. Let's go to lead code and let's solve this question using maps so that we get even more clarity about the data structure. So here's the question. Given an array nums of size n, return the majority element. Okay, so what's the majority element? The majority element is the element that appears more than a floor of n by 2 times. Okay, and you may assume that the majority element always exists. Okay, so they have guaranteed us that the array or vector that they are providing us always has a majority element. So like we don't have to take care of like cases when there's no majority element, right? Cool. So now that we have that, let's try to code it. What we'll be doing is the approach which we can be using, which we will be using is we'll take the array, we have the vector here, nums, and then we'll just iterate over the elements one by one. So if I take an example, say this one, so it's 3, 2, and 3. I'll maintain a variable called threshold, which is going to be equal to floor of n by 2, because I know that if I have an element which crosses floor of n by 2 number of occurrences, then that has to be with the majority element, and then I can just break out of the loop. I don't need to search any further, right? So for like making sure that we, for using the counter, right? For the counter, we will be using the map data structure. So we have 3 to 3. I'll be initializing a map int type. So for every element, the map is going to hold the corresponding count of that element, right? So for example, if I have 3, so I'll go to map of 3 and then I'll increment the position by 1, right? So I'll get 1 there. The next time I get 3, I'll go back to 3. 3 already has 1. I'll increment it by 1 more and I get 2. And then I see that, okay, so 2 is like greater than the threshold value. And once that happens, we can just break out of the loop and we're done, okay? So let's try to code it. First of all, let's define the threshold. Uh, threshold, and this is going to be equal to the size of the array. That's nums.size divided by 2. Um, but that's not always going to be the case. This is going to be the case when we have like even number of elements in the nums vector. So we'll just add 1 to it. So what happens is that if I look at this, nums dot size is 3 and by 2, 3 by 2, we know that since it's an integer type, it's going to store it as 1 and not as 1.5. So nums dot size by 2 is going to store as 1, but we clearly see that even 2 has an occurrence of 1. So we don't want the loop to break out at 2, right? So we'll just add 1. So we are looking for slightly more than like 1 more than half of the array. So it's like after we get an element which has like 2 occurrences, we will just break out of the loop and we'll declare that element as the majority element. And like if we just try our logic on this sample case too, then it's like 2 2. So the size is 1 2 3 4 5 6 7 7, and 7 by 2 is going to give us 3. 7 by 2, yes. So 7 by 2 is going to give us 3, but then we can again see that 1 is the element which has like 3 occurrences, but we don't want that. We want 2 here which has 4 occurrences, so we'll just add 1 to it. Right? Okay, so that's done. We have defined our threshold. Now let's define the map which we'll be using. So here we can clearly see that the order of the elements don't matter. And as we had discussed previously, we will be using an unordered map here. All right. So let's use an unordered map, and it's going to have int type. That's because like the element which we are storing is an integer, as well as the frequency of that element is also an integer, right? So I'll call this MP, and I guess that's it, and then I can start iterating. So remember from our previous discussion, like how do we iterate over elements in a vector. So I had already told you that I prefer this method. So like kv pair is the name of the element, and for every key value pair in the map MP, we are going to iterate it. Okay, but first of all, let's do this. We need to store the values in the map first, and then we will be iterating over it, right? So for auto, every element in the nums array, right? So we're taking every integer. So we're taking 3 2 3 like that. We're taking every integer, and now we'll be pushing it into the map. So element plus plus. Okay, I don't think I had mentioned this before, but like every place, like every value in a map is by default assigned 0, right? So if I do MP element plus plus, so by default the initial value, if this element was not already present in the map, would have been 0, right? So when I do MP element plus plus, it's going to be 0 plus plus, which is equal to 1. Okay, so now that position is having the value of 1. Now I don't want to iterate unnecessarily through the entire vector if I've already found the majority element. So what I'll do is that I'll put a check here that if MP if the frequency of that element is already greater than equal to our threshold. All right, then there is absolutely no need to continue further, and we can just declare one of them as the majority. So I can write this majority equals to say by default, let's keep the majority element as the first element in the vector. And if we get the element which crosses the threshold, then we can reassign the majority. Majority equals to that particular element whose frequency has crossed the threshold, and then we can simply break out of the for loop, right? So we have broken out of the for loop, and at the end, if I look at the function here, it expects an integer type to be returned. So we can just return the majority value here, majority value. Okay, so this should work. Let's see. Okay, so that does work. Let's try to submit the code and see whether it accepts it or not. Okay, awesome. So we've just completed this, and you can clearly see how we are using maps. I think one of the things which I had not mentioned in the previous discussions was the fact that maps are pre-initialized to 0 by default. So that's something to keep in mind while you are using maps in C++. Other than that, that's it. We use an unordered map because we didn't want any kind of order in our data. But in case we did, we would have gone for ordinary maps, right? We know that maps sort the data in ascending order, sort the keys in ascending order, right? So that's something to keep in mind. And you can use maps, unordered maps, multimaps, or unordered multimaps as and when you require, right? Based on the question, what the question is asking. So yeah. I hope maps and all its friend components and containers are uh, you're clear with, and associative containers in STL are really important. So I hope you are clear with them, and you can just loop through the video once more if you have any doubts. So thank you.
Hello everyone, I am Samarth, a member of Competitive Programming Department at IoT Lab, and today I'll be explaining two topics, stack and set. First, I'll start with stack. It's a simple and easy to understand data structure, yet I see people are confused. So today I'll try to explain it in the easiest way possible. मान लीजिए हमारे पास एक ये डब्बा है और हमारे पास 4 बिस्किट हैं W, X, Y और Z। इसमें पहले हमने W डाला इस बिस्किट के डब्बे में, फिर X, फिर Y और फिर Z। अगर मुझे आगे जाके मन किया कि मैं X बिस्किट खाऊं, तो इसके लिए मुझे इस डब्बे में से पहले Z निकालना पड़ेगा, फिर Y निकालना पड़ेगा और फिर मैं X खा पाऊंगा। तो इसका मतलब ये एक बेसिक प्रिंसिपल पे काम कर रहा है जो कि है लास्ट इन फर्स्ट आउट, LIFO, लास्ट इन फर्स्ट आउट। आई होप इट्स प्रीटी क्लियर एंड इजी टू अंडरस्टैंड। C++ में इसी बिस्किट के डब्बे को, बिस्किट का डब्बा, C++ में इसी बिस्किट के डब्बे को हम स्टैक कहते हैं। ये बहुत ही यूज़फुल डाटा स्ट्रक्चर है क्योंकि इसमें इंसर्शन और डिलीशन दोनों का टाइम कॉम्प्लेक्सिटी कांस्टेंट रहता है, जिसके कारण ये काफ़ी ज़्यादा यूज़ में भी आता है। तो पहले, अब जब हम समझ चुके हैं कि स्टैक काम कैसे करता है, अब हम देखते हैं इसके बेसिक फंक्शनैलिटीज़। तो स्टैक के पाँच बेसिक फंक्शंस हैं जो काफ़ी ज़्यादा यूज़ होते हैं। वो है empty, push, pop, size एंड टॉप। अब एक मैं नया कंटेनर लेता हूँ जिसमें मैं उन्हीं 4 बिस्किट को ऐड करता हूँ, W, X, Y, Z। तो अब अगर मुझे ये बिस्किट का डब्बा क्रिएट करना है, तो पहले तो मैं एक नॉर्मल डिक्लेयर करूँगा एक डब्बा। तो इस डब्बा का डिक्लेरेशन है स्टैक, और इसमें क्योंकि मैं कैरेक्टर्स डाल रहा हूँ तो इसका डाटा टाइप होगा कैर, और कोई भी एक नाम आप देना चाहें, मैं यहाँ पे ST दे देता हूँ। इसके बाद हमें सबसे पहले देखना है कि हम सबसे पहले एलिमेंट कौन सा ऐड करना चाहते हैं। तो हमने ऐड किया स्टैक डॉट पुश में कैरेक्टर W। तो अब जो हमारा ये नया है इसमें हमने w डाल दिया, फिर इसके ऊपर हम पुश करेंगे स्टैक डॉट पुश x, तो अब हमारा कंटेनर दिखेगा, w के ऊपर x आ जाएगा, इसी तरीके से y, और फिर इसी तरीके से z। और अब जैसे मान लीजिए मुझे चेक करना है कि अब मेरे स्टैक में कितने एलिमेंट्स हैं, तो इसके लिए सिंपल है, आपको बस करना है प्रिंट, मतलब जो भी जिस भी लैंग्वेज आप सिंटैक्स लिखें, प्रिंट करना है स्टैक का साइज। अब जैसा कि मैंने ऊपर एग्जांपल दिया था कि मुझे इसी कंटेनर में जिसमें z, y, x और w है, और इसका ओपन एंड है ये ऊपर वाला, और इसमें से मुझे x बिस्किट खाना है, तो सबसे पहले मैं एक एलिमेंट ऊपर से हटाऊंगा। इसके लिए मैं लिखूंगा स्टैक डॉट पॉप। स्टैक डॉट पॉप क्या कर रहा है, ये ऑटोमेटिकली जो एलिमेंट टॉप पे है ओपन एंड से, क्लोज एंड का इसमें कोई काम ही नहीं है, ये है ओपन एंड, यहाँ से ही सारे टास्क हम परफॉर्म कर रहे हैं। यहाँ से z रिमूव करेगा, तो अब हमारा स्टैक दिखेगा y, x और w, सॉरी यहाँ पे w आएगा, x और w। अब हमारा स्टैक ये है। अब क्योंकि मेरे पास अब भी x नहीं आया है, वो ऑलरेडी उसके ऊपर ऑलरेडी एक और एलिमेंट है, तो मैं फिर से एक और एलिमेंट रिमूव करूँगा स्टैक डॉट पॉप, ये एक और एलिमेंट हटा देगा। और अगर मुझे देखना है कि अभी जो मान लीजिए अभी मैंने पॉप किया, तो अभी मेरा कंटेनर दिख रहा है ऐसा x और w, और अगर मुझे देखना है कि अभी टॉप पे मतलब सबसे ऊपर का एलिमेंट जो मुझे खाना है वो x है कि नहीं, तो उसके लिए मैं प्रिंट कर दूंगा स्टैक डॉट टॉप। ये ऑटोमेटिकली हमें जो सबसे ऊपर एलिमेंट होगा स्टैक में वो दे देगा। तो यही इसके कुछ बेसिक ऑपरेशंस हैं, और अब मैं चाहता हूँ कि आप इसका प्रैक्टिकल नॉलेज भी रखें। तो एक क्वेश्चन है कि हमें एक ब्रैकेट बैलेंसिंग का क्वेश्चन ये लेते हैं हम, ये बहुत ही फेमस टॉपिक है जो स्टैक से सॉल्व होता है। तो द क्वेश्चन इज कि हमें चेक करना है कि हर एक क्लोजिंग ब्रैकेट के हर एक ओपनिंग ब्रैकेट के लिए हमारे पास एक क्लोजिंग ब्रैकेट भी हो। जैसे एक स्ट्रिंग लेते हैं हम, यहाँ पे मैंने 3 स्ट्रिंग ली है, और मतलब मुझे इसमें आउटपुट करना है यस और नो, हर एक ओपनिंग ब्रैकेट के लिए मेरे पास एक क्लोजिंग ब्रैकेट है कि नहीं। तो इसमें देखेंगे जैसे इस ओपनिंग के लिए ये क्लोजिंग है, इसके ओपनिंग के लिए ये क्लोजिंग ब्रैकेट है, तो इसका आउटपुट है यस। इसके लिए हमारे पास ये है, लेकिन इसके लिए हमारे पास यहाँ कुछ प्रेजेंट ही नहीं है, तो इसका आउटपुट है नो। और ये क्लोजिंग ब्रैकेट है, लेकिन इसके पास हमारे पास कोई प्री एग्जिस्टिंग ओपनिंग ब्रैकेट है ही नहीं, ये मिसिंग है, तो इस केस में भी हमारे पास नो आ जाएगा। तो I would highly recommend you guys for you to solve it on your own, and if you are unable then you can follow up with me. Now let's see how we'll code this logic. तो मैं अपना एक ID खोल लेता हूँ, और इसमें मैंने पहले से एक लाइब्रेरी इंक्लूड कर रखी है बिट्स std++। इसमें जितनी भी लाइब्रेरी C++ में है वो सारी इसमें होती हैं, लेकिन फिर भी अगर आपको बिना इसके करना है तो हमें इंक्लूड करना पड़ेगा एक स्पेसिफिक स्टैक के लिए, स्टैक। तो ये भी वही काम करेगा, लेकिन क्योंकि मैंने ये ऐड कर रखा है तो हमें इसकी ज़रूरत नहीं पड़ेगी यहाँ पे। तो अब एक स्ट्रिंग ले लेते हैं, एक स्ट्रिंग s है, और इसमें हम सिर्फ ओपनिंग और क्लोजिंग ब्रैकेट्स देते हैं, जैसे ये और फिर ये। तो ये एक वैलिड है, और हमें ये चेक करना है एक प्रोग्राम से। तो सबसे पहले मैं एक बूलियन डिक्लेयर करता हूँ, बूल वैलिड, और ऑप्टिमिज्म के कारण मैं इसको 1 से डिक्लेयर करता हूँ क्योंकि मैं चाहता हूँ कि वो पहले से वैलिड रहे। और अब हम चेक करेंगे, तो इसके लिए मुझे एक स्टैक क्रिएट करना पड़ेगा। तो स्टैक का सिंटेक्स बहुत ही सिंपल है, स्टैक फिर डाटा टाइप और जो भी नाम आप देना चाहें, तो यहाँ मैं फिर से st दे रहा हूँ। अब हम उस स्ट्रिंग में इटरेट करेंगे, और हम चेक करेंगे कि हर एक ओपनिंग जब भी मिले हमें तो उसको हम स्टैक में ऐड कर लेंगे। जैसे ये देखिए लॉजिक पार्ट है, ये लॉजिक पार्ट ये है कि अगर हमारे पास ये है तो हम इसको स्टैक क्रिएट करने के बाद इसमें जैसे ही हमें एक ओपनिंग ब्रैकेट मिलेगा हम उसको स्टैक में डालेंगे, फिर अगला ओपनिंग ब्रैकेट मिलेगा हम उसको स्टैक में डालेंगे, और फिर जैसे ही हमें क्लोजिंग ब्रैकेट मिलता है हम चेक करेंगे कि स्टैक में ओपनिंग ब्रैकेट है, तो अगर है तो हम इसको यहाँ से बाहर निकाल देंगे क्योंकि फिर इसका और इसका एक पेयर बन रहा है। तो अब स्टैक में हमारे पास सिर्फ एक ही ओपनिंग ब्रैकेट बनेगा क्योंकि इसको तो हमने पॉप कर दिया इस ऊपर वाले को, तो सिर्फ नीचे वाला बचा। और अब फिर एक और क्लोजिंग ब्रैकेट हमने इनकाउंटर किया तो हम चेक करेंगे इसके लिए हमारे पास एक ओपनिंग ब्रैकेट है कि नहीं, तो फिर अगर है तो हम इसको भी बाहर निकाल देंगे। तो इस तरीके से हम पूरा स्ट्रिंग इटरेट करके चेक करेंगे कि ये वैलिड है कि नहीं। तो इसी लॉजिक को हम कोड कर रहे हैं। तो फॉर int i इक्वल्स टू 0, i लेस देन s डॉट साइज, जितना स्ट्रिंग है उतना ही, और i प्लस प्लस इफ s ऑफ i इक्वल्स टू एक ओपनिंग ब्रैकेट है तो हम इसको स्टैक में पुश करेंगे, स्टैक डॉट पुश अच्छा, या फिर हम ऐसा भी कुछ भी लिख सकते हैं आप, ऐसा भी लिख सकते हैं क्योंकि ये कंडीशन है तो आप लेफ्ट और राइट इक्वल साइड के दोनों भी लिख सकते हैं। एल्स इफ अगर हमें एक ओपनिंग ब्रैकेट मिलता है तब तो प्रोसीजर सिंपल है, लेकिन अगर क्लोजिंग हमें मिल रहा है तो हमें चेक करना है। तो पहले तो हम ये देख लेंगे कि एस ऑफ आई इक्वल्स टू एक क्लोजिंग ब्रैकेट है, और ये बहुत इंपॉर्टेंट है कि स्टैक डॉट साइज इज नॉट इक्वल्स टू 0। इसका मतलब अगर स्टैक एम्प्टी हो गया तो इसका मतलब हमारे पास इस क्लोजिंग ब्रैकेट के लिए एक प्री एग्जिस्टिंग ओपनिंग ब्रैकेट है ही नहीं। तो इस कंडीशन के बाद अगर एस ऑफ आई क्लोजिंग ब्रैकेट है और स्टैक 0 नहीं है तो हम स्टैक में से सबसे टॉप का एलिमेंट पॉप कर देंगे। एल्स हम वैलिड को 0 कर देंगे क्योंकि अगर इन दो कंडीशन में से कोई भी सेटिस्फाई नहीं हो रहा है तो वो हमारे पास एक वैलिड नहीं है। इस पूरे प्रोसीजर के बाद हमें एक कंडीशन और चेक करना पड़ेगा कि इन सभी इटरेशन के बाद स्टैक हमारा एम्प्टी हो। तो इफ स्टैक डॉट एम्प्टी, हमारे पास ये ट्रू आना चाहिए। ये एक बुलियन फंक्शन है जैसा कि आप देख सकते हैं बूल std, तो ये हमारे पास 1 आना चाहिए। और अगर ये हमारे पास 1 नहीं है, इफ़ नॉट इक्वल्स टू 1, तब भी हमारा वो वैलिड वाला बूल 0 हो जाएगा। और अब हम सिंपली इस वैलिड बुलियन की वजह से हम आउटपुट कर देंगे कि वो वैलिड है कि नहीं। तो सी आउट अगर वैलिड है तो हम यहाँ पे यस आउटपुट कर देंगे, और अगर वो वैलिड नहीं है तो नो। आई होप दिस इज प्रीटी क्लियर, दिस इज द टर्नरी ऑपरेटर। अच्छा, और फिर यहाँ पे अगर ये वैलिड है, मतलब वैलिड अगर 1 है, अच्छा इसको ऐसे कर देते हैं, अगर वैलिड इक्वल्स टू 1 तो हमारे पास यस आना चाहिए और नहीं तो नो। तो अब इसको एक बार रन करके देख लेते हैं। अच्छा ईडी, सॉरी वो टेम्पलेट में मैंने डिफाइन कर रखा है ये। तो हमारे पास ये तो बैलेंस था जो कि हमें पहले से ही पता था। अब एक हम दूसरा स्ट्रिंग डाल के देखते हैं जो कि वैलिड नहीं हो। जैसे यहाँ पे मैं इसका ऑर्डर तोड़ने के लिए एक और ओपनिंग ब्रैकेट लगाता हूँ, और अब हमारे पास ये नो आ रहा है। तो आई थिंक दिस इज प्रीटी क्लियर।
Hello everyone, my name is Hers. I am from IoT Kit from CP department, and today I am going to share my knowledge on queue with you all. So let's get started. I will just give you a very brief description of what is queue, and we will just jump direct into the code. So yeah, definition written here: a queue is a linear structure which follows a particular order in which operations are performed. We will understand it with example. Everybody needs example, right? Nobody understand without example. So assume it is as a ticket counter. TC means ticket counter of a railway station. I hope everybody has seen what a ticket counter queue is been like, right? So basically each person is standing behind others, person 1, person 2, person 3, and they are standing at the back of each other. The person who is standing in the front will get the ticket first, and the person who is standing at the back will get the ticket at last, means after that person. So what happens is, suppose fourth person, the fifth person will come here, that fifth person will not come, cannot directly come here. So the person who get inside the line first will will take the ticket at first and come out of the line. The person who goes in last will come out of the line at last. This is basically what queue is. P4, that is first in, first out. The person who goes in first comes out first. The person who goes in last comes out last. And let's implement this. This is the basically idea of queue. What is a queue? And we will implement this using C++, and we will take help of STL. Let's get started. And yeah, if you have any doubt, you can write in the chat box. Our team will try to clear all the doubts, and for resources you can check in the description box. Okay, so let's get started. First we will include some libraries, IO stream, and we will also include queue because we want to work on the queue, so we have to include it using namespace IDD std name space std, and we will define our main function. This was the basic common means. We have tried this almost in every code, obviously not that queue part, but this much almost every code. So yeah, so first start with the queue. So how we define our queue? It's as simple as that. We are defining any other variables. So queue of type int, it will store int data types with queue. So this statement basically means that we have created a queue which will contain only and only integer types. So for example, on a railway station, there are sometimes, not always, it's almost in always all the railway station there are two queues, one for gents and one for ladies. So the gents queue can only store, means it can only ladies can go in the ladies queue and only the gents can go in the gents queue, right? So basically here it's almost the same thing. In int, the only int data type can go in int queue, and if you will define it as a string, then only string can only go in that, right? So if you will define a string, so only strings can go in that. So but we will want to work with int as of now. So let's see how many functions are there in the queue. So they are back, in place, empty, front, pop, push, size, swap. Only this function is pretty simple, right? We will first see the push function. What does push function do? As the name suggests, push function pushes the elements in the queue. So we will first make our another queue. Yeah. We will make our fresh queue. Queue is equals to, so this is our fresh queue. For example, we are as of now our queue is empty, right? So our queue is completely empty, and suppose we push 10. So what this push function basically do? It will push the queue, push the element 10 to the first position. First position in the sense where since there are no elements, so it will come at the first. Suppose that after we again push one element, suppose we push 20. We can push any element, 10, 20, 1, 0, any integer, because we have declared that integer type. Cool. So if we have, here it is 10, and if we have pushed 20, 20 cannot go here, 20 cannot come front of it, 20 will go here. So push function will basically push the elements to the last place, right? If you push again, q dot push, let's push 33. So 33 will go here. So yeah, this is a push function. Push function basically pushes the element in the queue. It's just for insertion of the element, right? And the another function I want to discuss with you is clear. I think if any have any doubt, you can mention in the chat box, so we will try to clear it out, right? Queue.empty. So queue.empty, what it does, it tells whether a queue is empty or not. So why you will believe me, I will print it out and show it to you. Queue.empty, or not empty, empty. I will get to in place what it is, but as of now we will want to see what is empty. So I want to ask you one question: if is our queue is empty or not? Obviously our queue is not empty. We stored all the 3 elements, so it should not show any empty. So let's run the terminal. G++, what's our program name? Queue dot cpp. So see, it shows 0, means our queue is not empty. And in that case, if our queue will be empty, what it will show? Obviously it will show 1. You all have predicted, I guess. I have not saved it, or what? No, sorry, I have to recompile it. Yeah, it shows 1. So if our queue is empty, it will show 1, and if our queue is not empty, it will show 0. Clear, right? Yeah. So the push function and the empty function we have cleared. So let's make a note for you. What does push function do? Push function pushes the element in the queue. What does empty function do? Okay, I should mention the empty sign, right? It tells whether spelling is wrong. Okay, WHETHER, whether queue is empty or not. So as of now, we have seen 2 functions. Okay, let's see this one. This one is iterating bit. Now let's print out the queue. So to print our queue, we will make a function to print our queue. So print queue, QUE, and we'll pass queue. So what is queue print function? Let's make our print function first, then we will discuss further on this. So it's a return type will be void because it's not returning any value, it's just displaying a value. So print queue, q, and it will be of type int because yeah, we have declared it as type int, and let's say it as queue only. And what we want to do, we want to print it. So how to print a queue? Queue dot empty. I will tell you the logic, but let me write it first. So what it will do, it will iterate until and unless and until the queue is not empty. So if any element exists in a queue, it will iterate, right? So what we will do, cout queue dot, see there is one function called front. The front function, what it does, it returns the first element in the list, that is a person standing in the first of the queue. So it will return 10. So whatever element will be there in the front function will return it. So dot front, and let's add a space to it to make the output more clear. And what we will do, once we have printed this one, we will pop this one. That is means we will remove this one from here, right? So that another 20 can print. So let me queue dot pop, and I have already told you the only element that can be popped from the queue is from the front. The pop function cannot remove 33 directly here or 22 directly from here. No, it cannot remove. The queue has a property, the first in first out. Whichever element is there in the first, that element only can be popped out. Cool. So queue.pop will basically remove the element from the first. So yeah, let's run it. Queue.pop, it will print it, and everything is fine, I guess. Yeah, let's remove this one. We already know what empty function does. And let's try to recompile our code, and let's hope there is no error in it. Yeah, 10, 20, 33. What are queue content? 10, 20, and 33. So I'll just explain once again how it is going on. So we have just created a queue. We have pushed some elements in it. 10, 20, and 33. Let's make it 30. It will look good, right? 10, 20, and 30. And we have just tried to print the queue. And how we are printing the queue? We are iterating over the queue unless and until the queue is not empty. And we are printing the queue. We are printing the front element of the queue. And we are just popping. So if you will not pop, it will iterate forever, because if you will not remove the element from the queue, it will only print the front element, and it will goes on. It will create an infinite loop. So the pop function will remove the element from the first, right? Yeah, this one is clear. So we have got one more function, that is pop. Two functions actually, front and pop. Front gives the more good word will be return, right? Returns the first element of the queue, right? of the queue. This all code will be shared with you all, so don't worry, you can just sit and enjoy. But yeah, I will motivate you to go along with me and write this code. Why it is showing error? I don't get. Yeah, this silly editor. Or anything I did messed up or what? Nope, nothing. And we also saw the pop function. It will basically remove the element from the first, removes the element from the first of the queue or top of the queue or the first element of the queue, anything you can say, from the first of the queue or the top of the queue. Oh, where's my pen? So the first it will basically, the pop function will remove this 10, and the first element will become 20 here. Then after we will insert 30, after we remove 20, then first element will be 30. Then after that the queue will over and our loop will terminate, right? So yeah, this was this much. We have seen push, empty, front, pop, and there is one more function that is back. The same opposite of the front is back. You can obviously predict what is back. It will print the element from the back, right? So I will just show it to you. Don't waste time. See out and back. Q dot, okay, sorry, Q dot back. See, it basically returns the value we added last. I will mention it here. Back. Returns last value of the queue. But before proceeding, we will just optimize it further using a for loop. Obviously, you cannot insert 100 elements by just writing the hard coding it, right? So int I, we will initialize it with 10, and let's go up to 10, right? So I less than equals to 10, I plus is equals to 10. It basically means that it will I will initialize from 10, and it will go sorry, it's not 10, it will be 50. It will go, it is unless it reached 50, and it will increment by 10. And we can use that push function. So q dot push I. Yep, this one is much more optimized. Remove from here. See, we have seen the back, we have seen empty, we have seen front, pop, push, and size function. Yeah, I'll tell you what is a size function. Size function, as the name suggests, it will just return the size of the queue. So I will just print it here and show it to you. See out size of the queue is q dot size. Simple. Okay, let's hit code runner. Yeah, 10, 20, 30, 40, and 50. Our for loop is working fine, and the size of the queue is 5. Correct. So just include one more. What is the meaning of size? So size function returns the size of the queue. The queue is very pretty simple in this one. It does not require much more effort. Returns the size of the queue. There is one more function called in place. Q dot in place also pushes the elements in the queue, but it is different from the push. I will not discuss what in place function actually do. You can just Google it and see if you have interest. I encourage you to Google it. It will be nice for you. The in place function also pushes the elements. If I will write in place any integer, it will push the elements at the back of the queue, but it is different from the push. So I will just encourage you to Google it, and so it will be lengthy to explain. So in place. Yeah, these are all the pretty basic functions of the queue. So I hope everything is covered in the queue. Queue.push pop swap. Swap basically just swaps a two queue. For example, there is Q1 and Q2. So it will just swap the queue. Let me show it to you. Example, it's Q and QINT Q1. Let's Q1 dot push I plus 1. And suppose now what we want to do, we want to swap Q dot swap with Q1. So here we are printing the Q, and in this one we will print the Q1. Cout Q1. Our function was print Q. So here the first it is of Q, it is 11, 21, 31. So our values are being swapped, right? So the swap function basically swaps the value of two queues. You can pass two queues and the value will be swapped of each other. So this was the basic queue implementation from STL. It's very easy to implement. Instead of writing your own push function, you can just use dot push and you can use all the function. It will yeah, it is right. But cool, everything is covered. So once we have understood what is queue, let's see what a priority queue is. I will just give a brief description of what a priority queue is. For any queries, you can write it in the chat box. So assume this is a simple queue. So what a simple queue is, we just push some element. For example, we pushed 1, we pushed 2, we pushed 3. So it will store the sequence in the sequence we have pushed it. But that's not what's case in the that's not the case in the priority queue. If we push 1, 2, 3, for example, q dot push 1, then 2, then 3, then what will happen? The element with the greatest value will comes at the top. That is, the resultant priority queue will be 3. But my mouse is not working. Pen is not working. Okay, no problem. 3, 2, and 1. Yeah. So yeah, it's working. It will be 3, 2, and 1. This is the priority queue. It prioritizes the element. It prioritizes the elements and adjusts the queue accordingly. So let's jump to coding and show it how it's implemented. Priority queue dot cpp. So yeah, these are some properties of the priority queue, that every item has a property associated with it. So for example, here 3, it has a priority associated with it. As of now, it has a highest priority. If I will insert 4, the 4 will have a highest priority. And second property, an element with the highest priority is dequeued before an element with low priority. Obviously it is stored in the first, so obviously it will dequeue first. So hence the element with the highest priority will be dequeued first. If two elements have same priority, they are served according to order in the queue. Let's rub it so that you can read this one. For example, if I will push 3 2 times, we have already 3 2 1. Yeah, 3 2 1. I will say it's no problem. So 2 and 1. And if we suppose we pushed one more 2 is already there, but if suppose we pushed one more 2, so in normal queue the 2 will be pushed at the last, but not in the case of the priority queue. The 2 will come just after the 2 we have already inserted. That is, it will give the same priority and they will serve accordingly in the queue, right? So let's see how it is implemented. I will just include some libraries, the same ones, that is IO stream, and the queue, because we want to, yeah, the priority queue is the extension of queue using namespace std. Now we will define our main function. To define our priority queue, we simply write priority queue of type int, because int should to be there, and the variable name should to be of pq. And to push the element, the functions are pretty much same. For pushing the element, it is push. For popping the element, it is pop. For to check whether the priority queue is empty or not, it is empty. To swap to priority queues, it is swap, so it will swap to values. We have already seen all these things in queue. The only difference, that is the spelling difference. In queue it is front, and in priority queue it is top. Yeah, so the top one will basically tell which element is at the top. But first I will go on each function separately, but don't worry. First we'll push some element. For example, we push 10, then we suppose we push to 5, pq.push 5. Then suppose we pushed pq.push 20, and let's push one more, pq.push 15. Okay, let's just push one more, just last one, pq.push 25. Okay, just push one more. Okay, I'm kidding. So yeah, and just make a print function for printing our priority queue. So print priority queue, print priority queue. For that, what we can do, just pass the element pq and read priority queue, and here I will say void priority queue. But till that time, I want you all to guess what is the output of this print priority queue. I push the elements first 10, 5, 20, 15, 25. If it would be a normal queue, then output should to be 10, 5, 20, 15, 25. But this is not the normal queue, it is a priority queue. So I would like you all to guess what is the output and write it in the chat box. Void print priority, spelling that priority queue. And to accept it, we will write, what we will write? We will write priority queue of type int, and just variable what you can send queue only. And for printing it, the logic is pretty much same. Not pretty much, is almost completely same. So queue dot empty. So we will iterate unless and until the queue is not empty. And queue is not empty, and we will see out queue dot top. So yeah, the top element, what it does, it tells which element is at the top, right? And to make the output beautiful, I will just add a space here, and then we will pop the first element. Yeah, so that next element turns will also come, right? Q dot pop this one out. So I hope you all have guessed what should be the output. Yeah, you all will write, I know, but let's see the output. Yeah, these are the previous outputs, I guess. Yeah, this one is the now present output. So 25, 20, 15, 10, 5. So all are being sorted in descending order. So this is what priority queue is. Prioritizes 25 for it. Prioritizes 25 more than 20, and 20 is prioritized more than 15, and 15 is more than 10, and 10 is more than 5. It goes on if we added more, if we would have added more elements. So what it does, it prioritizes the integers which are greater. The same thing can be done with the string. It will arrange it lexicographically. We will just see more functions, but first let's optimize this as we done in the queue. For I'll just copy it just to save our time, and also we are lazy. For now, we remove this PQ. So what it does now, we are inserting all the multiples of 10. So we initialize I is equals to 10, I less than 15, I plus is equals to 10. So it will basically first insert 10, then 20, then 30. But this is a priority queue. So what it will do, it will prioritize 50 first. So the output will be 50, 40, 30 like that. So yeah, just I will show you once. Why it is showing error? I is equals to 10. Don't guess error is there. Yeah, it's correct. 50, 40, 30, 20 and 10. Right, but we have first pushed 10, then 20. But it is all you know, it is a priority queue, so it will show 10 first. But what if we want to change it? We want we want to change it to ascending order. That first will be the smaller element, then will be the greater element. So how we will do that? For to do that, we will write here vector int. We will store a vector of int and a function greater int. So what it will do that it will change. What is error? Okay, I have to actually change here too, because I should change it here. So let's just copy it and paste it there. We will just copy and paste it here. Yep, this is cool, I guess. Now I want everyone that you should guess the output of this one. Only thing I have changed here, that I have written a vector, that is all the we have storing a vector, and then this function greater int. Let's see what will be the output. Why it is showing error? Yeah, it is correct although. 10, 20, 30, 40 and 50. So see here it was 50, 40, 30 and 20. Now the order has been changed. So yeah, you can change the order to it is completely customizable. So don't you think that it only gives priority to the element with the greatest integer. Even though you can make your own function and you can write it here. So it will compare the functions. You can write a compare function. I will not go much deep into the compare function. I encourage you to Google it and make that yourself. So what you can do here, instead of just writing a greater, you can make your own function and you can define it here. So it will based on the condition returning from that, it will prioritize all the elements in the priority queue. So yeah, this was a pretty small description of what is a priority queue is.
Hello everyone, this is Omkar Mohanty from the IT Lab CP team, and I'm here to demonstrate you about dequeues. So let's get started. So first things first, to use dequeues, you need to include the include the dequeues header file at the top. And to create a dequeue object, you need to specify the type of argument, template arguments, in which in this case we're using an integer. And let's say we are just taking the object type to object name to be a queue, right? So how do we insert an element in a dequeue? For that, there's many methods. So you type of here. For that, there's many methods here. First method is pushing back an element, which we can use by using queue.pushback, which just like a normal queue pushes back 13 to the end of the queue. Another method is push front, which adds in this case 11 to the front of the queue. So and last but not the least, but these two just put an element at the front and put an element at the back. But these do not, if you wanted to insert an element randomly at some position, this won't be helpful at all. Let's say we wanted to insert an element at the second position. We can't do that here in using push front and push back. So what's the solution? The standard library provides us a method known as queue.insert. but to use that we need to use an iterator. So let's declare an iterator called it, which points to the front of the queue. And because now it is pointing to the front of the queue, and if we insert it at that position, let's say 11, what it would do is, well, let's say 15 here because we have already used 11. If we insert 15 here, then it will insert it at the first position, which means it will just replay. It will just you'll see how it goes. As you can see, it just inserted 15 at the first position, but we wanted 15 to be at the second position. To do that, we must increment the iterator with one position. Let's say plus plus. We're incrementing the iterator by just one so that it points to the second position. Now, when we call it, 15 is inserted in the second position. Just like that, you can use it to insert at any position, be it the third, second, fourth, anywhere. So that was all about pushing and inserting elements inside a Dequeue. And this was when we have inserted 3 elements inside a Dequeue. Alright. So this was how we insert elements. So let's learn how you can retrieve elements from the Dequeue. So as we all know, Dequeue is just like a queue, isn't it? So the only elements we can actually access are from the front and the back. So there's actually a way to access it. So let's, because we are using an integer Dequeue, we have to use an integer. So let's say x is equal to q dot front. This will give the element which is present at the front of the Dequeue. And let's say x y is equal to q dot back. This gives us the element which is present at the back of the queue. So let's demonstrate it. Just to prove my point, I'm going to demonstrate what x and y are. Okay. As you can see, this is the Dequeue here, 11, 15, and 13. And the front is 11 and the back is 13, just like I said. So yeah, this is how we retrieve the elements at the front and back. Let's say now we wanted to delete elements in the queue. So how do we do that? It's quite easy. We just say q dot pop front, so pop front for for deleting an element at the front, which will basically delete the it's the element present at the front. So we will demonstrate the queue again here. I'm just making it a bit prettier to watch. Right. Let's see. So you can see the queue is initially 11, 15, 13, and the front is 11 and back is 13. Now we have popped the front, so it's just 15 and 13 in this case. And now when we pop the back, and we'll demonstrate the queue again. this is 15 now. So this was all about inserting, and then in this we learned how to insert, and then how to retrieve elements, and how to delete elements. But what if you wanted to get the size of the queue? For that we have queue.size. Right. This basically returns how many elements are there in the queue. So this was all about queues. Okay. And C++ standard library also has something known as policy-based data structures, which basically allows us to write data structures of our own which are not present in the standard template library. In this case, we are using a tree, and this is the example from Geeks for Geeks. And we're inserting element 5, then 2, 6, 4, and we're sorting them, and we're finding out the third in the value in the sorted array. If we're finding out what's present in the third index in the sorted array and all that. So this is all about the policy-based data structures. We'll run it for once, and we'll see what the results are. Yeah. So thank you. Hope you enjoyed this presentation about DQs and policy-based data structures. This is Omkar Mohanty signing off.